New in HyperLynx VX.2.10 and Simcenter Flotherm XT 2020.2 is the ability to execute a full co-simulation between HyperLynx DC drop and Flotherm XT thermal analysis. The temperature calculated in the Flotherm XT analysis will be used to dynamically update the power calculation during the HyperLynx DC drop simulation. Both tools will run concurrently and update the temperature and power calculations respectively. Let's first take a look at the thermal simulation results in Flotherm XT without any co-simulation with HyperLynx. We can see the hot area on the board near the FPGA and power inductors, looking at layer 8 and the top and bottom layers. In the results table view, we can see the max and average temperatures for each component on the board, as well as the calculated max fluid and solid temperatures of 146 degrees Celsius. Now we will set up the co-simulation with HyperLynx DC drop. In this design, we will follow the standard procedure to set up a DC drop simulation on our 1-volt power net. Executing the DC drop simulation, we can see a max voltage drop of 39.6 millivolts, and that the 1-volt power net is mainly located on layers 7 and 8. In Flotherm XT, the PCB has been imported in, relevant components have been assigned thermal models, and the overall solution domain has been defined. We can now point to the HyperLynx project file already set up for DC drop and select the 1-volt power net to run a full co-simulation. Once preparation and meshing are complete, Flotherm XT will initiate the initial DC drop iteration and will accept the power calculation back. After each Flotherm iteration, the temperature field within the PCB will be passed back to HyperLynx for an updated set of power calculation values to be returned. This process continues until the analysis converges or is halted by the user. Viewing the simulation results on the top and bottom layers as well as layer 8, we can see the hot area on the board surrounding the FPGA and power inductors just as before. Viewing the results in the table view, we can see that the max fluid and solid temperatures were calculated as 157 degrees Celsius, which is slightly more than 10 degrees hotter than the previous results without the power data from HyperLynx DC drop. Co-simulation between HyperLynx DC drop and Simcenter Flotherm XT can drastically increase simulation accuracy and provide engineers with more reliable thermal characteristics of their designs.